Swayam Prabha. Digital India. Educated India.
So, welcome to the NPTEL course on building energy systems and auditing, the module number 4 energy conservation building code that we are discussing, and this one is the last lecture on this module number 4, lecture number 20. So, we will discuss the ECBC recommendation for the daylighting. So, if you remember in the last lecture number 19, we discussed about the daylighting and mostly we discussed about the daylight factor. So, now we will take the daylight factor to the daylight autonomy and the useful daylight illuminance and all other part, and how that this UDI, this is the useful daylight illuminance, how that is calculated as per the ECBC, we will see in this particular lecture. So, first of all the daylight autonomy DA. So, what we have discussed in the last lecture as the daylight factor is a very static kind of a parameter, and because of the window aperture size, because of the orientation, this and that, the internal reflections, the other in the external reflections and all, VLT and aperture angles, everything if you take, and then you are getting a particular daylight factor, and that you convert the daylight factor to the lux level also based on your EO, the outdoor illuminance. So, that is a particular daylight, maybe you can say that is going to be available on that working plane for a particular day for a particular hour. So, it is a very static point, static parameter. Now, if you shift that particular the point, the coordinate changes, your all angle and other things will going to change. So, the value also going to change, that is number 1. Number 2, even if you take the same point and if you find out for the different part of the day, morning to evening, sun is rotate from the east to the west through the south in the northern hemisphere. So, based on the sun angle and all, this particular point locations of the interior will not going to have the constant and the similar type of the daylight throughout the day. Morning it may be less, evening it may be more if it is in the western part of the window is in front of that. If it is a eastern part of the window, the morning will be high and evening will be very less. If it is a southern part of the window, near to the southern part of the windows or so, then mostly it will be constant, little bit of mid part of the day, and then so this variation for each hour if I want to calculate for a day. So, I have to calculate maybe for 10 hours or something like that, or 6 hours to 10 hours depending upon the sun hours. Now, if I has to see that what is that particular daylight quality of over the year, so I have to do it for 1 year. So, all 365 day, all those 10 hours or 6 hours or whatever may be the possible sun hours, I have to do for the same. So, from that point of that particular concept, so it is a dynamic kind of a concept can be thought of for a daylight, not a static concept of only one single value of only one single parameter or so. For throughout the year, that particular space has what is the quality of the space based on the sunlight and all the sun angles and all. So, a daylight the autonomy DA is represented, whatever I have written, as the percentage of annual daylight time, that gives a point in a space is above a specified illumination level. So, if I say it is a DA 300, that means the daylight autonomy of 300, that means how much percentage of the day throughout the year that particular point will going to receive either 300 or more than 300 lux. So, that is going to be a very good parameter to know about, that yes, this particular point has a 60% of the year it will be going to be 300 or more than 300. So, something like that I have a perceptions of a space that or I should say that yes, then this is the quality of the space is good or bad or mediocre, whatever I may say. So, here suppose this is a particular grid I am talking about, and this grid I have calculated hourly. So, I just now I have discussed and I have calculated illumination level of the point for 365 days in a year, right. So, I have to do, because I may not do, my software may do, or there may be some other way, some thumb rules or whatever may do. So, but I have, my concept is I have to do for 365 days all for the hour, I mean for each day some daylight hour. So, out of that I have to count how many hours, how many amount of hours is more than 300 or so, and then I will use this calculation or formula, how many hours more than 3000 lux and total daylight hours available for this particular window, and that also depend upon your orientation, locations and all, latitude and all those, and multiplied by the 100. So, that will be the D at 300. So, that means it is a culmination of the total daylight hours in a whole year, depending upon the sun path, depending upon the orientation of your window, or maybe there are 2-3 windows or whatever may be, all take together, and that particular point has a particular potential amount of daylight, and this potential amount of daylight, if I say it is a, what is my bar? 300. So, how much is percentage of the hours is more than 300 for the whole year. So, that we have to calculate. So, here suppose this is the window, one small windows is there, and there is this room has some grids. So, suppose you calculate. So, mostly we see that this particular two area, this just next to the window, or these areas are will be very well illuminated, whether this area will not be so, right. This is the corner area, these grids will be not be so. So, for whole year if I calculate, so I may get those tick grids, maybe very high percentage of DA 300 or so, whereas this cross boxes I will get maybe very less percentage of, maybe somewhat, maybe in some summer days when there is a some morning sessions or maybe the afternoon sessions, I may get somewhere maybe some few hours. So, that may add up for some 3-4 months, can give me some amount of the more than 300 for this cross zones, corner zones, but mostly of the 90% time, 80% time, maybe I am expecting in those front areas, front zones may have more daylight than 300. So, if I see, that, and I have just for sake of the explanation, I have just thought of, I can show that this will be almost like 80. So, it is very close to the window and next to the window, next layer or so, this will be surrounded by 80. So, it will be something like 70% of the year, it will be around 300 lux or so. 80 does not mean that 80 lux, 70 does not mean that 70 lux, 70 and 80 means the 70% of the total annual time, daytime will be receiving a particular cutoff, which is my maybe 300 or so, if I want to use 300 as my cutoff. So, it will be little less. So, further less will be the 60 will be 60% of the DA will be this zone. So, gradually if you go towards the corners or so, and if there is no such window in other walls, it will decrease and going to be very low values in the corner. So, it will be 50 like this, it will be 40 like this, and maybe 30 and then 20, 10 or something like that. So, of course, this all are my for just for sake of the explain you, I have just gradually, I mean I have just given some numbers, it is may not be very accurate or so. So, if I go back again, so if I just run these things, this is 80, 70, 60, it is going decreasing and spreading towards 30 and 20 and 10 like that. Now, suppose the window are more, I mean instead of the 2 grid opening it is a 4 grid opening. So, more 80 you will get, more the 70 will be, and then finally, you should end up with 30 at the corners, where the other time you are end up with 10 percentage of the time in the corners are having more than 300 lux, but here maybe because of the increase of the wind width, same area, same orientation, you may end up with 30% in the corner. So, more area is illuminated. If you remember in the last slide, only maybe the 4 grids are 80, now it is 8 grids are of 80 or so. So, it is better illumination point of view, this particular window aperture or whatever is better. So, we can actually compare now by this particular the quality of the room because of the sizes of the window or the positions of the window, number of window, and we can say that this room is good and this room is better performing from the daylight point of view. So, I am not going to depend upon the only single value of the daylight factor which we have calculated in the last class or last lecture, and we are not only depend upon that only one value or 1 or 2, 3, 4 values very nearby areas or deep areas, and then say that this area is good or bad. No, you have to this daylight autonomy is going to give a throughout the yearly values, and that will going to give the quality of the daylight of a particular space, and then we can decide that is good or bad or mediocre. The next layer of this particular the daylight autonomy is the useful daylight illuminance UDI, and this is another level up. So, UDI is a kind of a modified version of the daylight autonomy. So, it is a modified DA you may say, and this particular concept was first established in 2005, and that was brought into the lot of codes, the green building codes and all from the daylight point of view. In fact, the ECBC also taken this particular UDI concept in the ECBC code for the daylight, and this is again a matrix bin, just like we have discussed. It is a matrix bin, you have to divide the whole the space into so many grades depending upon your software how much it can do, or the memory of the software and how it can run fast or whatever. So, the grades, and you should see that particular grid sense. So, 3 sectors, one is 0 to 100 lux. So, which grids are having 0 to 100 lux kind of a scenario, maximum time, maybe 50% time, 90% time, 80% time that, and the second grid is that the 100 to 200, and the third is over one is 0 to 100, second one is 100 to 2000, and the third one is over 2000. So, here the further range of this UDI is one is just now I told, where it is some bin, some areas, some your grids are showing that maximum time more than 50% or more than 70% of the time, that 50%, 70%, let us we decide, we will going to decide in my ECBC that what will be the, is it 50% time or it is 75% time, whatever. So, that we will decide. So, a certain amount of maximum amount of time is less than 100 lux. So, that means it is insufficient UDI, insufficient. So, that area the lighting levels are considered to be insufficient without electrical lighting. So, those area you require electrical lighting almost throughout the year. So, if your that bins, the space bins, some area is 10%, some area is 30%, you see that one. So, that may say no, this area will require daylight throughout the year also. Now, next one is the supplementary UDI. Supplementary UDI, you see the which area will be within 100 to 500, it is again not a 300 lux or so, it is a 100 to 500 lux. So, that particular area is the grids are having showing more maximum time is 100 to 500. Sometimes it is 100, sometimes it is 500 or sometimes 400, 300 whatever. So, it is in this range. So, this is called the supplementary UDI, where acceptable daylight levels is there and we can integrate with the electrical light. So, sometimes not throughout the year, but sometimes I may require some kind of supplementary electrical lighting, but not throughout the year. The third one is this 500 to 2500 autonomous UDI. So, that is acceptable. So, some of the area, most of the time it is more than 500. So, it is plenty, more than enough for any kind of a work, acceptable daylight level, because for reading and all these things we require 300, 400 maximum. So, 500 and more almost most of the time, most of the 70% or whatever time. So, electrical light would not be needed for the majority of the day, maybe sometimes it is a dark because of the overcast, the cloud and all, sky and all. So, those days mostly it will not going to required. Predominantly the daylight lit spaces required occupy for the period, and it may require sometimes it may require some kind of a glare control, because sometimes it may be high as maybe 2200, 2300 or so. So, you may require some kind of a glare control louvers or something like that. So, these are the 3 mostly we can use, and there are another 4 as per the nomenclature. Exceedance UDI, which is more than 2500, again it is massive. So, we are not going to use it, because using with this will be definitely come to a glare. So, you have to reduce the daylight in those area by some kind of bins and the blinds and all those, the vertical blinds and all. So, now this is the UDI criteria for the ECBC. So, that means you see if I am targeting the ECBC, if you remember we have 3 targets, so one is ECBC, one is ECBC plus and one is super ECBC. So, if I am targeting ECBC, if I am targeting a business school or those kind of educational institute, the 40% is the cutoff for that particular. So, 40% of my area should have the corresponding UDI value. 40% of the area, 60% of the area may not have, right. If it is a shopping complex, I can get UDI, I can get the ECBC daylight requirement only if it is 10%. But if I want to go for the super ECBC, it should be 20%, and in this case business and the educational school or whatever, it should be 60%. 60% will be the requirement. So, 60%, what 60%? 60% of the floor area, 60% of my classroom, 60% of my lecture theatre, 60% of my the faculty areas or whatever should have UDI requirement of the requirement is the sufficient kind of the requirement, or the earlier that the supplementary or the autonomous kind of the requirement. So, that is more than 300 lakhs or whatever. So, now, this is I want to tell you. So, suppose there is a educational building and this is suppose one classroom or something like that. So, count how many grids are there? There are total 40 grids. Why 40 grids? There are 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, 6, 7, 8. So, 5 and 8 is going to give you 40 total grids, right, the 40 grids. So, you see now, this is my educational building, I have cropped that particular table, the last table. So, if 16 grids are under this UDI criteria, then I am 40% of my floor space is under UDI criteria, because 16 by 40 is 16 is the 40% of 40, total 40 grids are there. So, suppose these are the 16 grids comes under the UDI criteria. So, I will get ECBC. Now, 50%. So, in case of the 50%, my 20 such grids will be under the UDI criteria in my floor. 50% if I want to achieve, not 16% will not going to do. I need to have the 20 grids under this. So, much more. So, maybe you have to increase the window, you have to place another window, you have to increase the depth of the window, whatever you can do, but you have to go with the more area to be illuminated, 20 grids should be illuminated. How to calculate this we will discuss just after this slide. Then I will get ECBC plus, because 50% of the windows are 50% the grids are under that UDI criteria and illuminated criteria also. But if I want to achieve super ECBC, at least 60% the floor area should be illuminated by that. So, at least 24 grids has to be illuminated. So, I have to again increase the some of the size, or you have to put more windows, maybe other walls or whatever, and you have to have those 24 grids illuminated under the UDI criteria, and you will achieve 60% of the whole area is that particular. Now, it will not going to be like a magic that this 25 16 grid and then 20 grids and then 24 grids, like that suddenly it is increasing. This increment is not a magic, it has to do some kind of the physical changes in the building, in the windows and in the building, mostly in the fenestration. So, you may have to increase your the VLT, you have to mostly you have to increase your window size, maybe you have to go for too many, instead of one window one side it may not be sufficient, you may have to add few more windows, and then only some physical changes of the window point of view is required. Otherwise, this grids from 16 to 24 or through 20 it not be achieved. It is not going to be like some other things that you will know. No, this is going to be the only some physical change of the window is required. So, let us see, and this will have to that 100 to 2000, that 90% of the autonomy is also. So, we have discussed that one, there is a E mean or E average also. So, we will see that particular how to do that shortly. So, let us discuss the uniformity ratio E minimum versus the E average that we have discussed. So, for the lit side lit the rooms uniformity lit ratio should be the 0.3 to 0.4, and top lit surfaces, that means if there is a skylight or some atrium or whatever, you have to have 0.7. So, the brightest part of the illumination, suppose this is the brightest part just next to the window. So, we see it is the illumination is almost 1500 lux and total number of grids are 6. There is a medium part of the illumination, those have 900 lux of the 26 grids under this, 26 grids under the illumination, there are 40 grids, and there are the darkest part of the room which is having 300 lux of the illumination, and there are 8 such grids. So, total if you add up 6 plus 26 plus 8 should be 40. So, what should be the average illumination? I have to take the weightage average. So, it is 870 lux, and what is the minimum illumination? 300. So, E mean by E average is 300 by 870 sorry. So, it is 0.34, it is quite good in that way. So, it should not be the average, and the minimum should have a kind of a parity or some kind of a good ratio. It is not that it is too dark and then the other side is too illuminated, that your average is too high. So, that will create a kind of the glare kind of issues or so. So, there are two rules that we are going to use to calculate this UDI criteria or so. So, first one is called the 2H rule. What is 2H rule? H is height. So, if the height of the window from the floor is H, that means it is not the actual height of the window, it is the height of the lintel or the top of the window from the where from the floor is H, and you may have a sill, you may not have a sill, you may have a window from the sill. So, there is a actual window aperture is smaller, or you may not have the sill, you may have the window from the floor itself, whatever may be. The H is the the height from the floor to the top, we may say that the 2h depth towards the room side, towards the space, there is a 2h depth from the top of the opening to 2h depth, you will get good illumination, you will get the good illumination. So, this criteria of course fall on the floor, not in the working plane, because what working plane may be here. So, this particular length is not 2h, it is little less than that, but we will discuss the floor as our criteria as per the ECBC. So, we can say till the 2h of the twice of the depth. So, if this h is 2 meter, so 4 meter from that. If it is 3.5 meter, so it is 7 meter from the wall side will be the illuminated properly as per the UDI 90% UDI criteria of 100 to 2500 kind of a thing. Throughout the year, that 90% of the time we may say it is going to be illuminated properly. So, that is one criteria to know the depth from the wall, how much is the illumination based on the height of the window or the top height of the window. And the second one is called the 1 meter rule. The 1 meter rule is that the what is the opening of the size, that is the width of the window, and 1 meter this side the right and 1 meter other side in the left, these two can be added together, and 2h we know, 2h already we know that is the depth from the wall, and this particular area will be illuminated and daylight area also. So, that this area can be think for the calculations. And there are other rules as a area 20 rule. So, the total area of the window should be 20% of the floor area. So, those are also can be used for our calculations or so. But we will use this 1 meter rule and 2h rule, that earlier one, the 2h rule for our UDI calculation in the next slide. So, for the guidelines of the UDI, so those are the guidelines, the working plane is assumed to be as 0.8 meter above the floor finish level, and from that this criteria has been developed, and all those kind of areas. The morning, if you want to do the simulations or so, you have to keep it in the 8 meter above the level, above the floor level, finished floor level, and there are total sunshine hours and all has to be calculated. For school it is some other hours or so. VLT also you have to take some amount. So, these are the some of the VLT reflectance of the room you can take. So, you can go through this, and this is suppose the thumb rule for the UDI calculations given by the as per the ECBC. Suppose we have a area of 12 meter by 8 meter. So, 12 meter by 8 meter is almost 96 meter square. So, I have 1 meter by 1 meter 96 such grades. But see, I have 3 windows, one is 3 meter by width and this one is 3 meter by, this one is 3 meter by 1.5 meter, 1.5 meter height is from the floor, and this is 2 meter by 1.5 meter again from the floor, and this is 4 meter by 2 meter again from the floor. So, like that. So, 4 meter is the width. So, by 1 meter rule and 2h rule, so I can say 2h means 1 meter means 1 meter this side the left and right, and 2h is it is 3 meter because h is going to be 1.5 meter. So, this is 113 meter. So, this will be my daylight area as per the UDI criteria. The second one is this, which is 2 meter. So, 1 meter the left side will be common for the other window, and this is 1 meter in the right side, and again it is 3 meter. And the third window which is 4 meter. So, it will go till this 1 meter rule, and this is 4 meter means 2 meters. So, 1, 2, 3, 4. So, till this you see it will be the illuminated, right. This will be illuminated. So, this will be illuminated. So, now you count how many squares are the illuminated. So, this 3 I have counted. So, total daylight area is 42 meters square. These are the 42 boxes or the squares are illuminated by virtue of that thumb rule 2h and 1 meter rule, and so it is 43% only. So, if it is a school, it will get only the ECBC, not the ECBC plus or super ECBC. Super ECBC requires 60%, ECBC plus required 50%, ECBC required 40%. So, it quite good for ECBC, not for super ECBC or ECBC plus. Now, see that same area I have a small chamber, suppose some small chamber if I place. So, this is I have calculated, this is again I have calculated. So, those are the calculations I have written down here. This is calculated also the same 42, those if you add up these 3 it will be going to be give you I think 42. But here delete area is 42 considering overlapping, but you see this area we should not be counted, because this area should not be deleted, because there is a partition wall. Because of this partition wall, this particular area will be dark. Okay. So, if it is open kind of a thing, then these 6 modules or 6 grids can be taken in my calculation. So, considering this area 42, so this is 96 by this is 43%. So, now I have to revisit, because now it is 36 meters square, because it was 42 earlier minus 6. So, this comes with 42 minus 6 is 36, this is minus 6, these 6 are the minus 6, these all are the 42, and then my new calculation is 37.5. So, if you put a room over there or something like that, you are not going to get the ECBC also, because you are less than 40% or so. So, like that with a very simple thumb rule, without going to go for the laborious software, the simulations, basic thumb rule point of view also we can check that whether my building or my school building or the classrooms are more than 60 or less than 60 or 40% or whatever, and what criteria I may get from the ECBC. So, that is all for this particular lecture on this particular module. So, in this module in fact, we have discussed about the whole the ECBC criteria, initially the EPF factors and all, and now we have discussed the daylight autonomy UDI requirement of the ECBC as per the Bureau of Energy Efficiency and ECBC code. Thank you very much.